Dear students, in this video lecture, we'll solve some of the numericals on the DC circuits. Let us solve the first problem. Two resistors 20 ohm and 40 ohm are connected in parallel. So this is 20 ohm and 40 ohm connected in parallel. A resistance of 10 ohm is connected in series. This is the resistance of 10 ohm is connected in series with this particular combination. A voltage of 200 volt is applied across the circuit. This is the voltage 200 volt is applied across the circuit. Find the current in each resistance and the voltage across 10 ohm, and also find the power consumed in all the resistances. Let us say first thing is you need to find out the current in each resistance, because the current which is flowing in 20 ohm, 40 ohm and 10 ohm means you need to, if you define it as the I1, the current flowing through that 20 ohm, the I2 is the current flowing through 40 ohm, and I is the main current which is flowing through 10 ohm. If I consider that, first you need to calculate what is the equivalent resistance. See here, 20 ohm and 40 ohm are connected in parallel. So when two resistors are connected in parallel, then how you calculate the equivalent resistance? It is 20 into 40 divided by 20 plus 40 plus 10. So we calculated the equivalent resistance, that is we got 23.33 ohm. Then if we treat this as a one particular resistance, then the voltage is 200 volt. V is equal to IR, or I is equal to V by R. V is the 200 volt, then R is the 23.33. Then the current, total current what we are getting is 8.57. 8.57 ampere is flowing through the 10 ohm, that is the main current which is flowing through that. Then how we are going to calculate the I1 and I2? This is most important. Branch current formula we are going to apply. So the current I1, if you want to find out, its opposite resistance is 40 ohm. So 40 ohm divided by 20 plus 40, that formula we are using. That is, the branch current I1 can be calculated as the main current into the opposite resistance divided by the addition of two resistors. So the main current is 8.57, opposite resistor is 40 ohm, then 20 plus 40 ohm, that is given here. We calculated I1 is equal to 5.71. So the main current we know, that is 8.57. then the one of the branch current we got, that is 5.71. then the remaining current which is flowing through the I2 is the main current minus I1, that is I minus I1. So 8.57 minus 5.71, so we got the current flowing through 40 ohm, that is I2 current is 8.6 amps. Now what is the voltage across 10 ohm? That is the current flowing through that into R. V is equal to IR. Current flowing is 8.57, the resistor is 10 ohm. So voltage across the 10 ohm is 85.7 volts. Then how we are going to find out the power now? That is I square R. P is equal to I square R, you can find out. So the current flowing through the resistor, so the power across the 10 ohm resistor is, the current flowing through the 10 ohm is 8.57 square into the resistor R10. It is, we are getting 734.45 watts. The power across, power consumed in 20 ohm resistor is I1 square into 20. I1 square is 5.1 square into 20. We got 652.08 watts. The power consumed by 40 ohm resistor is I2 square into 40, that is 2.86 square into 40, that is 327.18 watts. So this is how we are going to find out the equivalent resistance, the branch current, the main current, and the power consumed in all the three resistances. Now let us study the second point, that is the second problem, numerical 2. A resistance R is connected in series with a parallel circuit comprising of 20 ohm and 48 ohm. The total power dissipated in the circuit is 1000 watt and the applied voltage is 250 volt. Calculate the R. Let us study the statement once again. the resistance R is connected in series with the parallel circuit of 20 and 48. 20 and 48 are connected in parallel. For that circuit, R is connected in series. So he has given total power consumed by the circuit P, that is V square by R. Okay, RT. V square, V is given 250 square by RT, that is 1000 power consumed. Then we can calculate what is the total resistance, because they have given total power consumed. So V square by R. Okay, so with respect to that, we can calculate total resistance, that is 250 square divided by 1000. We are getting around 62.5 ohm is the total resistance of the circuit. Now if you want to calculate the equivalent resistance or total resistance of this circuit, how we can calculate? 20 and 48 ohm are connected in parallel. It is 20 into 48 divided by 20 plus 48. For that circuit, R is connected in series. So we know already total resistance 62.5 ohm. You substitute here. R is the unknown. 28 into 48 divided by 20 plus 48, 14.12 we get. Then the R value is 48.38 ohm. This is how you are going to solve the problem by using this method. Let us solve the numerical 3. Find the potential difference between the points X and Y in the network shown below. So here this is one branch, this is another branch. For these two, the voltage source is connected, 4 volt. Now how we are going to calculate the potential difference between X and Y? X is here, Y is here, X is here. Okay. Now we are going to find out first I1. How you are going to find out I1? 2 volt is connected here. 2 divided by 2 plus 3, it is I1 is equal to 0.4 amps. Then I2 is 4 volt. It is 4 volt divided by 3 plus 5. So we got the I2. It is 0.5 amps. Now Vxy, voltage across this potential difference, Vxy is calculated as the current I1 is coming this side. Then you are moving like this side. So it is plus 3I2 here. Plus 3I2. Then as it is minus 4, then you are coming like this. I2 is current, I2 current is also flowing like this. Both are at the same direction, so we are taking minus 3I1. So plus 3I2 minus 4 minus 3I1 is equal to Vxy. So I2 is known, that is 0.5 amps. I1 is known, 0.4 amps. So both are calculated. We are getting Vxy is equal to minus 3.7 volts. So Y is at the higher potential than the X in this particular problem. Let us study the fourth problem, that is find the currents in the various branches of the given network that is shown. See here in this network, first let me explain the network. This is A, B, C, D, E, F, A. It is the network. See 100 amps is coming here. Inside it is coming. Then it is moving like this. Then here 80 amps is going out. 80 amps is going out. So what may be the, if I take the current flowing through this branch is I, then 100 amps minus 80. So I minus 80, because 80 minus is going out. So the current flowing through this branch is I minus 80. Now come to this point. Sorry. Now 90 ampere is coming inside. So it is positive. So I minus 80 plus 90. So how much current will flow in this? That is I plus 10. Then at this 150 amps is going out. 150 amps is going out. So minus it is I plus 10 minus 150. So how much current flowing in this branch? I minus 140. Then come to this 120 amps is coming inside. It is positive. Then I minus 140 plus 120. This is I minus 20 is going in this particular branch. So here 80 amps is going out. 80 amps is going out. Okay. Sorry. 80 amps is going out. Okay. Then as already it is I minus 20 minus 80, the current I minus 100 is flowing here. So already all these registers are represented here. Then how we are going to write the equation now? You can see here. So I am also moving like this, the current is moving also like this, minus 0.02 I, then minus 0.02 I minus 80, minus 0.03 I plus 10, minus 0.02 I minus 140, minus 0.01 I minus 20, minus 0.01 I minus 100 is equal to 0. So on solving this, we get that the total current I is equal to 48.18 amps. So the current flowing through, the total current flowing in this is 48.18. Now you can see what is the current flowing through each branch, because already all the currents are represented in terms of I. You can substitute the current flowing through BC is I minus 80. So this is 48.18 minus 80 minus 31.82. You can calculate ICB, ID, all the currents can be calculated as shown in the figure. So this is how it looks very difficult, but it is very easy problem. You can solve it by using the simplest method. Now the fifth problem we'll see. The current in the 6 ohm resistance of the network shown in the figure is 2 ampere. Determine the currents in all the branches and the applied voltage. So here let me explain once again. The 6 ohm resistor is here. Here the current flowing through 6 ohm resistor is 2 ampere, it is given. Determine the currents in all the branches and what is the applied voltage. Applied voltage is also not given, only current flowing through one of the resistor is given. Let us study only this particular path. Now if I say the total current is the I, then how we are going to calculate the branch current, that is I2. Okay, now you know I1, then you are going to find out the I2. Let me calculate the I now. The branch current I1 is equal to, or 2 amps is equal to main current into opposite resistance divided by addition of 2. So that is 2 is equal to main current I into 8 divided by 8 plus 6. So we got the main current, that is 3.5 amps. So that is the current flowing through this. Then I2 current can be easily find out, because 2 amps is flowing here, total current is 3.5 amps, so current I2 is 1.5 amps, 3.5 minus 2, 1.5 amps. Now look into the I1 and the I3, how you are going to find out I1 and I3. So the main current flowing through this is 3.5 amps, so that is 3.5 into opposite resistor is 20 divided by 20 plus 8, you can find out I1, that is 2.5 amps. Then similarly I3 is I minus I1, you can find out the I3 as 1 amps. So the total voltage across this is 4 into I and 6 into 2 plus 8 into I1. So that is total the value of the voltage across the circuit is 46 volt. So that is how we are going to calculate the total voltage across the circuit, that is 46 volt. So this is how we are going to solve the problems on the DC circuits. In the next video lecture, we will talk on the next part. Thank you.